All right, guys. So just kind of some big picture stuff. Just remember with chapter 11, all the thank you, sir. All right, all the math excels and stuff are kind of optional. They're not going in the grade book. And you can do them. I put a due date on there only so it saves right for next year. Don't worry about that. If you want to do them after the due date to get ready for the final, that's fine. Whatever. It'll say you get half credit, but not going into the grade book this year. So anyways, use those as needed, and we'll go ahead and get to it. So yesterday we talked about permutations, combinations, and a little bit about the counting principle. So yesterday's was all about finding like a number of outcomes, a sample space, you could say. And today we're going to start to get into the probability end of it. And I think that's what the rest of our notes are about, kind of finding probability in different scenarios. So, this can be kind of fun, kind of challenging in a different way. Anyways, here we go. So probability is how blank an event is to occur. So let's change us to is there, is to occur. And that would be how likely an event is to occur. And it's somewhere between 0 and 1, also known as 0% and 100%. Okay, so there's experimental probability, and that is basically the number of desirable outcomes, the number of times something that we were looking for happened. Versus the total number of possibilities. Okay, so let's go ahead and jump on into it. Example 1 says, of the 60 vehicles parked in the teacher's parking lot today, 15 are pickup trucks. What's the experimental probability that a vehicle is a pickup truck and then is not a pickup truck? So probability of a truck would just be the 15 that's our desirable outcomes, and then the total outcomes would be the total number of cars. We could reduce that down if we wanted to. I think on your homework it mainly wants like a decimal or a percent. So if we divide there, we get 0.25. Or if you wanted a percent, obviously just move your decimal over 2 places, and that'd be a 25% chance. So then the probability that it would be anything else, or you could say not truck, would be the rest of the cars, right? So 45 out of the 60, or 75%. Let's see. The vocabulary term is not in there to say the relationship between those two, but if two events like add up to 100% or include the whole sample space, this is a C word. Does anybody remember what they're called? They are nobody. They're called complement. They're complementary, I guess. Complementary events. So. Not that you need to know that, but anywho, go ahead and try example 2 there. So we want the probability based on the prompt that this young lady gets a hit in her next at bat based on her previous 50. All right, so looking for 20 out of 50 there, which gives her a 0.4 chance, or if we wanted that as a percent, 40%. And if you're not a sports fan, you might think, "Wow, that's not very good." But 40% in baseball is an excellent batting average there. So. All right, so then getting into sample space, I already talked about this a little bit. This is kind of what we worked on yesterday. finding a sample space. So that is kind of the total. That's like your denominator, right? Whatever event you're looking at, your sample space would be like your denominator. So an example, a very common example, for probability is rolling a dice. In a math book, they like to call it a number cube for whatever reason. But the sample space on a die is integers 1 through 6. 1, 2, 3, 4, 5, 6. And then is it equally likely that you would get any one of those outcomes? Assuming that it's like not a weighted dice or something weird, yes, that would be, each one would be equally likely, right? So there's a 1 out of 6 chance you would get any one of those outcomes, right? So that's why, that's a common kind of problem. All right, so theoretical probability, so that would be, so we kind of, our previous examples here with the truck and with the hit, that would be experimental probability. So that's based on actual data. Theoretical is kind of based on, it says calculating the probability of it happening, not actually based on real data. Okay, but it's basically kind of the same thing. Number of desirable outcomes over total outcomes. So example 3, given a standard number cube, again, that's just dice. What's the theoretical probability of each event? So probability, we roll an even. So that would be, we know it's out of 6. So how many out of the 6 in our sample space were even? 3, yeah. So 2, 4, 6. If you want to write that, that's 2, 4, 6. Those are the 3. And so that would be a 50% chance, right? 0.5 or 50%. Yeah, yes, yes. So yeah, Nate said, didn't we do this in middle school? And the answer is yes, we have touched on some of this. Obviously we'll get a little more in depth, but this stuff for sure. Yes, yes, sir. All right, what about what's the probability then that we would roll a 7? How many 7s are there in our sample space? 0, right? So that would be impossible since it's not part of our sample space. All right, another common type of problem, and you kind of have to have some knowledge of a deck of cards for these, is picking a card out of a deck of cards, right? So we'll talk about this a little bit, but hopefully you have some knowledge. You're from Southern Indiana, at least the big cards for euchre, right? So anyways. All right, so what's the probability that we get a king? So we can see, here our sample space is going to be out of 52. So then how many out of those 52 are kings? 4, that's right. So there's 1 for each suit, right? There are 4, and then, just 4 divided by 52 would give us our decimal, which is 0.078. So about 7.8%. All right, and then face cards. So again, here's where we get into some of the terminology that could potentially give you some issues. First of all, what is a face card? Sure. What's a face card? Anybody know? Yeah, McGuire. Well, we usually don't consider like a joker in any of it, but assuming no joker. Yeah, so Jack, Queen, King, and I think we do count aces. Yeah, so anything above a 10. So you might want to make a note there, because that was a good point. I didn't think about that. So yeah, so Jack, Queen, King, ace, and then so if there are, if there are 4 kings, then there are 4 of each of those. Actually, sorry, we don't count ace. I'm sorry. It's 12. It's 12. I'm sorry. Yeah, it's 12, not 16. That's what it says on the notes. Yeah, so don't include an ace. I'm sorry, I was wrong about that. So 4, 8, 12 out of the 52. So we're just going to triple our probability for the last one, right? So if we divide there, it's going to be 0.23, so just less than a 1 out of 4 chance. All right. So why don't you guys go ahead and look at the next couple. So we're looking at a bag of Jawbreakers. There are 15 red, 10 orange, 8 green, 7 purple. So find the following probabilities based on that. See what you get. All right. Anybody want to take a stab at red or orange? What did we get for red or orange? Mr. McLean. Very good. All right. So, the probably knew what to do with the or, but that's just add the two totals together. Obviously, you needed to start by finding the total number in the bag, but then add red plus orange. That would be 25 out of 40 is 62.5%. Very good. And then what about probability of not green? So anything else besides green? Sorry. 80%. Very good. So the easiest way to find not green would be, just 40 minus green, right? So 40 minus 8 would be the quickest way to get to your 32, and that would give you 0.8 or 80%. All right, so everything's pretty straightforward so far. Anybody have any questions? All right, if there is anything that's a little bit difficult on this lesson, it's this example 6. So when we're picking out like a handful of stuff, so this will go back to kind of what we did yesterday. So I've actually never heard of this term till I was looking over these notes, but combinatorics. I bet, and also I've never really worked these problems out the way that they do in the book. So if the way that I show you how to do these doesn't make sense, Maddie, you can let me know, and I can show you a different way. But if it does make sense, then we'll just stick with the way they show it in the book, because that'll match up with the Math Excel stuff, anyways. All right. So, anyways, our scenario here is we have 30 zombie movies and 10 action movies. Sounds like we need to maybe expand our horizons a little bit. Where's the comedy and stuff? Come on. Anyways, we're gonna randomly grab 6. So what would be the probability of all 6 of those being zombie movies? So here is how you can set that up. So basically, you want to do the probability that we grab 6 zombie movies is going to be, we're going to do 30 zombie movies, and we get a combination of 6. And then we're going to divide that by all of our movies and a combination of 6. Okay, so you know, a little bit challenging to maybe type that in. So this is from yesterday. So let's go ahead and remember how we could type that in. I don't know why my calculator, oh, on the wrong side. So here is how that would look in your calculator. So you'll type in your 30 first, and then you go into math, and everything's under probability. And we would want NCR here. So, and then 6. So that's my numerator. I'm going to arrow out, hit divided by, and then my denominator is 40. C6. All right, so that's going to give me, looks like about 15% chance that all of them are zombie movies. I'm going to say that's about 15%. All right, so what about if they were all action movies? So go ahead and write out how you think we would set that up, and if you want to go ahead and start typing it in, you can. So if we did all action movies was 30 C6 over 40 C6, how would we do for all action movies? What would that look like? And if you don't know, just wait a second. All right, so what would so the denominator would be the same, 40C6. What would my numerator be if you think you 10C6? That's right. So yeah, you just have 10 to choose from, still choosing 6. Has anybody typed that in yet? It's going to be a lot smaller chance. What do you think, Mr. McLean? Yeah, so yeah, about 4 zeros before the 5. So if we were talking percent, that'd be 0.005%, right? So not going to happen, in other words. So about 0.005%. Okay, but what you'll see on your calculator is 4 zeros, right? So when we put that percent sign on, we're moving it 2 to the right. Okay. All right. So then the last one, even a little bit tougher. So if we do not a group of one thing, we have to kind of set it up like this. So you want to kind of think of it like this. So you do, this would be another way to say this would be the probability of 2 zombie. And then we're going to multiply that by the probability of, we're getting 6, right? So 4 of the other. So before we get into the math of it, is this going to be more or less likely than the last thing? Why is it going to be a little more likely? It is going to be very unlikely, but it's going to be a little more likely than B. Why? Anybody? Just on a big picture kind of thing. Yeah, because we get 2 zombie, right? So that any zombie is going to increase our probability a little bit. All right. So anyways, here's how we would set it up. And again, this one's tough. I don't know if you have any, on your homework that are this tough, but basically we would go like this. So the 2 zombie would be, 10. Wait, what's zombie? Zombie is 30. Sorry. 30 C2 over 40 C6. And then here's where it gets a little bit tricky. So then our 4 action would be 10C4. Nothing too weird about that. What kind of changes is in our next fraction, we're only left with 38 movies to choose from. So that's where this one gets a little bit tricky. So it would be 38C4 instead of 40C4. And then after that, it's a little bit tough to type in. So I'll give you a chance to try to type this in because there's a good chance you might type it in wrong. So give it a shot. I'll give you, 30 seconds, a minute to try to type that in and just see if we're matching up decimal to decimal there. And then that'll be it. If your number is it's going to be between 0 and 1%. So, well, that doesn't really help us too much, but your answer is going to be in the tenths of a percent. How about that? That narrows it down a little bit. All right, so your decimal is, and again, keep in mind this is a pretty tough one. It should be about 0.2%. So it's about 0.002 if you type it in right. So that equates to about 0.2%. So again, not gonna happen, right? So again, I kind of like when I did teach this in middle school, we get a little more in depth with it, spend a little more time on it. I would teach these a little bit of a different way. Again, I've never really heard the term combinatorics, but I can show you guys a different way to do this if you want. But for now, just so the notes kind of match the help me solve this stuff, I'll leave it here and do the other thing off video if you want to see another way. So besides that, that's it for the day.